welcome to FEM Expert. In today's tutorial we're going to show you how to perform a negative backlink analysis on a complex structure. More so, we're going to explain to you how to interpret the results and work with it, since we're going to work with a little bit more complex structure than what we worked before. So for that, in that purpose, we have here some key points and some lines. We're going to copy and paste this. And we're going to look at the structure that we are obtaining. Here we have it. We'll go to line plotting, and we're going to put this structure as like X, Y, and Z like that. So what we have here is a cube with the dimensions of 1 meter, having a variety of different beam elements. So we're going to perform a backlink analysis, but we're going to show you that you might obtain a negative backlink coefficient, and it's not that simple to interpret these results in more complex structures. So we're gonna go here and we're gonna define the element type. We can copy it from here, or we can just follow. I'm gonna put this on the side and I'm just gonna follow this. Element type 188. So element type 1 is gonna be beam 188. We're gonna define the properties, material property density 7,850 kilograms per cubic meter. Material property Young's modulus for material 1, 2.1 E11, the Young's modulus of steel, 2.1 E11 pascals, and material properties PRXY, material 1, 0.3. Now we're gonna go and define a section for these cubes. So we're gonna go on sections, beam, common section. We're going to do section 1 is going to be phi 100, so it's going to be a round section of 100 millimeters in diameter, so 100 divided by 2000, and we're going to go and just do an L mesh. We don't necessarily care about the elements per unit here, so L mesh comma all. We have the material, we have the properties. We're going to do E shape. I'm going to check our structure. It's a simple structure, quite big, heavy structure. We're going to do E shape 0, 0, replot, and we're going to put the restrictions at the bottom, dk, p. We're going to restrict all of these three corners, all of degree of freedom 0. Then we're going to apply an acceleration of 100 meters per square second, 100 on the y direction, and minus 100 on the z direction. So this is a complex acceleration. It has values on all of the directions, and the idea is to obtain this negative backlink behavior in order to evaluate the results and understand what's happening. So we're going to go and perform that static analysis, solve. As you can see here, the results, well, we can analyze the results. P and sol, use sum. So the deformation of this PL vect U will be towards, kind of like towards the inside. We also have negative, so we'll be a little bit diagonal inside. It's a little bit more complicated because the way we have the restrictions and the way the structure will be acting, right? We're going to see this again. So the maximum display is at this corner, and what we're going to do is go again on solution. We're going to do an analysis, eigenbacklink, okay. Yes, analysis option. We're going to get the first mode, the mode center, and we're going to see what we obtain. So solve. The solution is done quite fast. Read results and by pick. So the first mode that we get is minus 518.63. We're going to read it, and this is way more complicated to understand. This would mean that if you multiply the acceleration by this value, you would obtain this, but the acceleration has three components. So the one that has the motive for this backlink could be one or the other. This is not anymore that simple. We're going to try to guess if maybe the z direction was the one that's to blame, and see if we obtain the first mode as positive because the way we're doing it. So we're gonna go back to solution. We're going to apply the acceleration, so it's going to be 100, 100, and 100. We got to change the type of analysis, static, do a solve. We verify the solution, yes. So now we go to solution, new analysis, eigenbuckling, okay, okay. Analysis option again 1 and solve. So now we go and look at the results by peak, and we still have a negative one, so it's a different value, it's a different PL vect U. It's a different PL sol U sum. It's a different component, it's a different way of having the backlink. This backlink, the value is different, but of course this is not this would not be completely fine with us, depends on your situation. Another option that you have here is going to the analysis. Instead of doing the AM backlink as centered, you can do modes in range, and it would provide the first mode that's positive if you have it positive at some point. So I'm gonna go to here and general post-processing by peak, and this 569 is the one that was positive, so that would be that value. So we would have compression that would be requiring a smaller coefficient, but would determine, it could determine backlink. If we would having extension that would not be determining backlink, but it could determine if that force is fluctuating. And if we only had the non-fluctuating force for the compression components on the extension on the compression components, we would have backlink here. As I said before, this is not a very simple way to this is not a very simple solution to analyze. The results are not trivial, but if you perform this analysis, you can perform other types of analysis. At least you have an idea on how this structure is going to behave, and well, the most important factor is having this factor correctly determined and understanding what its function. So thank you for watching our tutorials. If you like our tutorials, please subscribe to our channel and like our videos. Thank you very much.